A Weg SSW-03 series soft starter tripping on a 100 horsepower motor, but working with smaller motors, indicates several potential issues. Firstly, the thyristors may be degraded or damaged. Over time, thyristors can suffer from degradation, or they may become damaged due to voltage surges or other electrical issues. This can lead to partial or intermittent failures, causing the starter to trip. Secondly, there could be faults in the starter's control circuit preventing proper gate drive signals from reaching the thyristors. This results in erratic operation or a complete failure to function correctly. Thirdly, some SSW-03 series variants use insulated gate bipolar transistors or IGBTs instead of thyristors. If the IGBTs fail, the starter won't effectively control the motor current, leading to vibrations and tripping. Fourthly, the use of undersized star-delta contactors can cause excessive current flow during the star-delta transition. This can trigger the starter's overload protection, causing it to trip. Fifthly, the soft starter might be calibrated for a different motor impedance than the one currently connected. This results in improper current control and potential tripping. To troubleshoot: 1. Inspect the thyristors. Visually check for any signs of damage or overheating on the thyristors. Then, use a multimeter to test for continuity and shorts. 2. Check the control circuit. Measure the gate drive signals to the thyristors and verify that the pulses are clean and within the specified range. 3. Inspect the IGBTs. If applicable, test the IGBTs for shorts or open circuits using a multimeter or an IGBT tester. 4. Verify contactor sizing. Ensure that the star-delta contactors are correctly sized for the motor, referring to the starter's manual for specific recommendations. 5. Calibrate the starter. Check the calibration settings and adjust them as necessary to match the motor's impedance. 6. Isolate the motor. Disconnect the motor from the starter and test it independently to rule out any issues with the motor itself. When inspecting the thyristors, look for discoloration, cracks, or any other visible signs of physical damage. A multimeter can be used to perform diode tests on the thyristors, checking for forward voltage drop and reverse blocking capability. A healthy thyristor should exhibit a forward voltage drop between the anode and cathode when triggered and should block voltage in the reverse direction. If a thyristor shows a short circuit or open circuit, it is likely defective and needs replacement. For checking the control circuit, use an oscilloscope to examine the gate drive signals. The pulses should have the correct amplitude, pulse width, and timing as specified in the soft starter's documentation. A missing or distorted gate drive signal indicates a problem with the control circuit, possibly involving faulty components such as transistors, resistors, or integrated circuits. When inspecting the IGBTs, similar to thyristors, look for visual signs of damage such as cracks or burnt marks. Use a multimeter to test for shorts or open circuits between the gate collector and emitter terminals. An IGBT tester can provide more comprehensive testing, assessing the IGBT switching characteristics and gate drive requirements. Defective IGBT should be replaced with components that meet or exceed the original specifications. To verify the contactor sizing, check the current ratings of the star-delta contactors and compare them with the motor's full load current and starting current requirements. The contactors should be rated to handle the motor's starting current without overheating or experiencing excessive voltage drop. Consult the motor's nameplate and the soft starter's manual for guidance on selecting appropriately sized contactors. If the contactors are undersized, replace them with appropriately rated components. For calibrating the starter, consult the soft starter's manual for detailed instructions on adjusting the settings. The parameters to check and adjust may include starting voltage, ramp-up time, current limit, and overload protection settings. Use an ammeter to monitor the motor current during startup and adjust the settings to achieve smooth acceleration without tripping the overload protection. If the motor impedance is significantly different from the starter's calibration, it may be necessary to recalibrate the starter or choose a different soft starter model that is better suited for the motor. When isolating the motor, use a megameter to test the insulation resistance of the motor windings. Lower insulation resistance indicates insulation breakdown, which can cause ground faults and tripping. Check the motor's bearings for signs of wear or damage, and lubricate them as necessary. If the motor is suspected of having internal faults, consult a qualified motor repair technician for further diagnosis and repair. Also ensure the motor is properly grounded to prevent electrical hazards and ensure proper operation of the soft starter's protective functions. Check the grounding connections between the motor, starter, and electrical panel for corrosion or loose connections. Clean and tighten any loose connections and replace corroded grounding wires. A good ground connection provides a low impedance path for fault currents, minimizing the risk of electric shock and equipment damage. Soft starters often have built-in diagnostic features that can help identify the cause of tripping. Consult the soft starters manual for information on interpreting the diagnostic codes and using the built-in troubleshooting tools. The diagnostic codes can provide valuable clues about the nature and location of the fault, helping to narrow down the possible causes. Also, check the soft starter's input voltage to ensure it is within the specified range. Overvoltage or undervoltage conditions can cause the starter to malfunction and trip. Use a voltmeter to measure the input voltage and compare it with the starter's voltage rating. If the voltage is outside the acceptable range, investigate the power supply and correct any voltage fluctuations or imbalances. Check the soft starter's cooling system to ensure it is functioning properly. Overheating can cause the starter to trip or experience component failures. Verify that the cooling fans are running and that the heat sinks are free from dust and debris. Clean the cooling system as needed to maintain proper airflow and prevent overheating. Check the connections and wiring between the soft starter, motor, and electrical panel for loose or damaged connections. Loose connections can cause voltage drops, overheating, and intermittent operation. Tighten any loose connections and replace damaged wires. Use a torque wrench to ensure that the connections are tightened to the specified torque. Also verify the integrity of the control wiring and communication cables. Damaged or improperly shielded cables can introduce noise and interference, causing the starter to malfunction. Replace any damaged cables and ensure that they are properly shielded and grounded. Check the soft starter's bypass contactor, if present, to ensure that it is functioning correctly. The bypass contactor is used to bypass the soft starter after the motor has reached full speed, reducing the heat generated by the starter. If the bypass contactor is not functioning properly, the soft starter may overheat and trip. Test the bypass contactor to ensure that it closes and opens as commanded. Also verify the condition of the overload relays or electronic overload protection devices used in conjunction with the soft starter. These devices protect the motor from overloads and short circuits. Test the overload relays to ensure that they are properly calibrated and functioning correctly. If the overload relays are faulty, replace them with properly rated components. Finally, consider the environmental conditions in which the soft starter is operating. Extreme temperatures, humidity, or corrosive atmospheres can accelerate the degradation of electronic components and cause the starter to malfunction. Protect the soft starter from harsh environmental conditions by enclosing it in a suitable enclosure and providing adequate ventilation. In addition, consider the possibility of harmonic distortion in the power system. Harmonic distortion can cause overheating and malfunction of electronic equipment, including soft starters. Use a power quality analyzer to measure the harmonic content of the power system and take steps to mitigate any excessive harmonic distortion. This may involve installing harmonic filters or using line reactors to reduce the harmonic currents. If the soft starter is connected to a generator, verify that the generator's voltage and frequency are stable and within the specified limits. Fluctuations in voltage or frequency can cause the soft starter to malfunction. Also check the generator's capacity to ensure that it can handle the motor's starting current without excessive voltage drop. The soft starter settings may need to be adjusted to compensate for the characteristics of the generator. Furthermore, examine the motor's load to ensure that it is not excessive or fluctuating. Overloads or sudden changes in load can cause the soft starter to trip. If the motor is driving a pump or fan, check for obstructions or damage to the impeller or blades. If the motor is driving a conveyor or other mechanical equipment, check for worn or misaligned components. Correct any issues with the motor's load to prevent overloading and tripping. Additionally, review the soft starter's application to ensure that it is appropriate for the motor and load. Soft starters are not suitable for all applications, and using the wrong type of starter can lead to problems. Consider factors such as the motor's starting torque requirements, the frequency of starts and stops, and the ambient temperature. If the soft starter is not the right choice for the application, consider using a different type of motor starter, such as a variable frequency drive or a reduced voltage auto transformer starter. Also, verify that the soft starter is properly configured for the motor's connection type, such as Y or Delta. Incorrect configuration can cause the starter to malfunction and trip. Check the wiring connections to ensure that they match the motor's connection type and the soft starter's configuration settings. Consult the soft starter's manual for detailed instructions on configuring the starter for different motor connection types. If the soft starter has been recently installed or reconfigured, double-check all of the wiring connections and settings to ensure that they are correct. Even a small error can cause the starter to malfunction. Use a checklist to verify that all of the required steps have been completed and that all of the settings are correct. Pay close attention to the wiring connections, voltage settings, current limits, and overload protection settings. Furthermore, consider the age of the soft starter. Soft starters, like all electronic equipment, have a limited lifespan. Over time, components can degrade and fail, leading to malfunctions. If the soft starter is several years old, it may be nearing the end of its lifespan and may need to be replaced. Consider replacing the soft starter with a newer model that incorporates the latest technology and features. Additionally, check the soft starter software or firmware version. Manufacturers often release updates to address bugs and improve performance. Ensure that the soft starter is running the latest software or firmware version. Consult the manufacturer's website for information on available updates and instructions on how to install them. Finally, document all of the troubleshooting steps that have been taken and the results of each step. This documentation can be helpful in identifying patterns and trends and can assist in future troubleshooting efforts. Keep a log of all of the settings and configurations of the soft starter, as well as any changes that have been made. This documentation can be invaluable when troubleshooting complex problems or when replacing the soft starter. By systematically following these troubleshooting steps and carefully examining the soft starter, motor, and associated equipment, it should be possible to identify the cause of the tripping and resolve the problem.